All right, we're going to take a look at a few of the random problems from the 10.2 and 10.3 worksheets. So 10.2, arithmetic, for a sequence, we're looking at a sub n equals a sub 1 plus n minus 1 times d. So here in this first section, they're asking about a specific term. Let's look at number 2 together. They want the 19th term, so we're looking for when n equals 19. Then they give us the first 3 terms of the sequence. So we can see there that 16 is the first term. That's your a sub 1. We can also determine d, which is the number that we're adding over and over again. It looks like we're adding 16 every time. So we have the information we need. So we're looking for a sub 19. It's equal to a sub 1, which is 16, plus n minus 1. Well, n is 19, because we're looking for the 19th term. So 19 minus 1. Times d, which is 16, because we're adding 16 each time. So ultimately, that's what we're going to do. We're going to take 16 plus 18 times 16 is 304. So the 19th term is 304. Let's look at number 4. Here we're just looking for the nth term rule. So we don't have an n value. We do know our first term, that's a sub 1. And we want to know what d is. What are we adding from one term to the next? Well, to do that, if you're not certain, especially since we have rather large numbers, you can take the negative 232 minus negative 416 to work backwards. We see that it's 93. That means we're adding 93 from one term to the next. Okay? So now I know everything from my formula. First term plus, I don't know what n is, n minus 1. Times d, which is 93, I will distribute. And I'll combine like terms then. So I have negative 416 minus 93 to get negative 509. So 93 and minus 509. Okay, arithmetic means, let's look at number 5 together. From one term to the next, since it's arithmetic, I know I'm adding a value. I'm adding d over and over again. We do it once, looks like we do it twice, and then a third time, and yet once more we add d 4 times. So I'm going to make an algebra equation to represent that. I started at 17, I added d 1, 2, 3, 4 times 4d, and I ended up at 41. So now I can figure out what d is. So subtract 17 from 41, we get 24. Divide by 4, we see that d is 6, so I'm adding 6 every time. So if I'm adding 6 every time, let's go ahead and do that. We started at 17, add 6, we get 23. Add 6 again, you get 29. Add 6 again, you get 35. There's the 3 missing ones. If you add 6 again to 35, you get 41, which is what it should have been. So we know we did it correctly. Now, in the next section, we're finding the sum of the series. Since it's arithmetic, I'm using the formula S sub n equals n times a1 plus an all over 2. So number 7 rather. We'll do number 7. We know our first term. That's 1. We know our last term. That's a sub n. That's for the 43. What I don't know, though, is n. I need to figure out what n is. So to figure out what n is, I go back to my sequence formula, and I plug in 43, because I know 43 is my last term. I'm going to plug 43 in for a sub n, and then I'll be able to figure out what n is. So let's do that. I'm plugging 43 in. My first term is 1. I don't know what n is, so it still says n minus 1, but I do know that I'm adding 3 over and over again. So d is 3. We can now figure out what n is. So over here, I'm kind of running out of room, so 43 is equal to 3n minus 2. Add 2, 45. 3n equals 45, so n equals 15. So now I can go and find the sum of those 15 terms. It's equal to 15 times the first plus the last divided by 2. So 1 plus 43 is 44. Half of that is 22. I have 22 times 15 is 330. Okay, I'm going to jump down to number 11, with summation notation. It's still a series. It's just a different notation. So I still need to know my first term. It does tell me at the bottom that n is 1. That's my first term, so I want to find a sub 1. So to find that, you just plug 1 into the formula. 2 times 1 is 2, minus 3 is negative 1. There's my first term. Then I need to know my last term. What's my last term? Well, it tells me on top the fifth term, a sub 5. So to get a sub 5, you just plug 5 in. 2 times 5 is 10. 10 minus 3 is 7. And then what's the n value? N value is how many terms there are. So if I'm going from term 1 through term 5, term 1, 2, 3, 4, 5, that's the first 5 terms. I'll use an n value of 5. So the sum of those 5 terms is equal to 5 times your first term plus your last term, which was 7, divided by 2. Negative 1 plus 7 is 6. Half of that is 3. 5 times 3 is 15. Be careful on a problem like number 14. Same strategy, but notice they don't start with 1. They start with the fifth term. So the first term I care about is actually a sub 5. Plug in 5 to find out what it is. 4 minus 3 times 5. 3 times 5 is 15. 4 minus 15 is negative 11. That's the first term I care about, so I won't actually find a sub 1. The 12th term, plug in 12. 3 times 12 is 36. 4 minus 36 is negative 32. What's the n? How many terms are there? Not 12, because I didn't start at 1. I started at 5. 5 through 12, if you subtract them, that's 7, but you have to add 1 because we're including both of them. So that's 8 terms total. You can count out on your fingers if you want. Term 5, 6, 7, 8, 9, 10, 11, 12. That was 8 terms. You can count out if you have to. So the sum of those 8 terms is equal to your 8, the n value, times your first term, which was negative 11, plus your last term, which is negative 32. Divided by 2, you can finish it from there. Let's jump down to number 15. We're trying to find the first 3 terms. All right, let's see. What do we know? We know the sum. We know s sub 1, so we're going to use the same formula. So the sum is 175. So plug in the formula. Do we know what n is? We don't know what n is. Then it calls for a sub 1. A sub 1 is 4. Then it calls for a sub n, which the last term, which is 31, divided by 2. So 4 plus 31 is 35. Half of that, 17.5. So we have so 175 equals 17.5 n. Divide by 17.5, we see that n is 10. So now we still haven't answered the question, but I know that this is the 10th term. A sub 10 equals 31. Now I need to figure out what d is. But if I go back to my original sequence formula, this one up here, I'm going to plug in 10, or the 31, the last term I have. That's probably what I would choose to do. I'm going to go down, continue on down here. My last term was 31. First term was 4. When I was at 31, its d value, or its n value, I just found it was 10. So plug in 10 for the n value. Minus 1 times d. So now I can figure out what this is. 9d, subtract 4, 27. Equals 9d, so d has to be 3. Finally know what d is, so now let's go ahead and find the first 3 terms. The first term was 4. It gave me that. Now add 3. So if you add 4 to 3, you get 7. Add 3 again, you get 10. So there's my first 3 terms. That's for question number 15. A little bit of work on that problem. Let's go to 10.3. Geometric. So a sub n here equals a sub 1 times r to the n minus 1. It's the formula. So if I look at number 2, I'm looking for the 6th term. They want to know what a sub 6 is. First term was 20 times r, which is negative 3 to the power of n minus 1, but I know n is 6, so 6 minus 1, which is really 5. I'm going to take 20 times negative 3 to the 5th. I get negative 4,860. Okay, I'm going to jump down. I'll take a look at number 10. Now they want it just in terms of n, a sub n. So your first term, negative 1, times your n, what are we multiplying by? Looks like we're multiplying by 5 to the n minus 1. Done. Number 13, actually no, I'm gonna jump to number 15. Just have more room to work over here on the side. So sum of a series. We actually have two formulas. Depending on what information we have, we can use a sub 1 minus a sub 1 times r to the n over 1 minus r. Notice that one doesn't use a sub n. Okay, that's the advantage to that one. The other one is a sub 1 minus a sub n times r to the 1 minus r. That one uses a sub n, but it doesn't use n. So as I look at number 15, I see that the first term they want me to use is 2. So I'm going to have to find that. So I'm going to be using this in place of a sub 1, but really technically it's a sub 2 because that's what it tells me to start with. Let's plug 2 in. So, and for an exponent, 2 minus 1 is 1. We have an exponent of 1. Negative 1 to the 1 is 1. 9 times negative 1 is negative 9. I'll also have to know the 32nd term. Well, perhaps. I got a decision to make. Do I want to use the 32nd term and use the second? Or do I want to use what n is? Honestly, I'm expecting that this, actually it's not going to be that hard to do because our n value is negative 1. So it's not going to be that big of a deal. So maybe I'll just go with a sub 32. So plug in 32. 32 minus 1 is 31. Negative 1 to the 31. Since it's to the odd power, it's going to be a negative 1. So I have 9 times negative 1 is negative 9 again. What's happening here, if we're multiplying by negative 1, it's going negative 9, positive 9, negative 9, positive 9, negative 9, positive 9. It's just alternating is all that's happening on this problem. Kind of a weird sequence or series. What is my r value? R is what we're multiplying by every time. That's the number that got raised to the exponent. That's negative 1. So let's plug them all in the formula. I chose to use the second formula since I found a sub 32. So s sub n, I didn't find out what n was, doesn't matter. First term was negative 9. Minus my last term, which is negative 9. Notice the double negatives. I can go ahead and make that positive. Times r, which is negative 1. Over 1 minus r, which is the negative 1. The double negatives there, they can become 1, positive 1, or 1 plus 1. So it looks like I have a negative 9, and then this ends up being another negative 9. So in total, that's negative 18 up there, over 2, which is negative 9. So that's my sum. Kind of a strange series, like I said, but that's how we would do it. Let's do one of these problems down here. Maybe I'll do number 17. Notice this one gives me an n, so I'm going to use the first formula, the one that has an n in it. So I know the sum is 1512. I don't know my first term. That's what they're actually asking us to find. Minus a sub 1 again, times r, which is 2, to the power of n, which is 6, over 1 minus r, which is 2. So I'm going to factor out a sub 1 from the numerator. So end up with 1 minus 2 to the 6th. That's all over negative 1. So I'm just going to multiply by negative 1 to get rid of the denominator. So now I've got negative 1512 equals a sub 1 times, well, let's see what 1 minus 2 to the 6th is. I'll just do it on the calculator. 1 minus 2 to the 6th is negative 63. So now I'll divide by negative 63. So negative 1512 divided by negative 63 is 24. So I see that the first term is 24. All right, hopefully that helps you get rolling on